Hey everyone, so today we are going to solve this problem in which the problem statement is nth Fibonacci number. So what is the problem is like you have you're given you will be given a value of n. So for that n you have to find the Fibonacci number. So what a Fibonacci number is going to be. So suppose you have been given in that zeroth Fibonacci number is 0, first Fibonacci is 1, second Fibonacci is 1 also. So, and what Tribonacci number is, it's been listed in the definition that suppose you have n plus 3th Tribonacci number you have to find. So it will be the sum of all the sum of the last three previous of that. What it means is that suppose you want to find the fourth Fibonacci, it will be third plus second plus first. If you want to find the eighth Fibonacci, it will be seventh plus your sixth plus your fifth. So that it means that is Fibonacci number. So you can do it with the recursion, that is pretty easy, but the time complexity is going to be about big of 3n 3's power n in that case. So we need to optimize that solution. So how we are going to do it, let me tell you about that. So we know the past result because the current result is completely dependent on the past result. So we can make an array for so that we can store all the past results and use it in our current to find our current result. What I mean is that let's say if I want to find I haven't given 0th, first and second, so let's say if I want to find the third Fibonacci number, what it's going to be. For that I know third Fibonacci is going to be the sum of previous three, which will be what, second plus first plus the 0th. That will be second is what, 1 plus 0, that is going to be equal to what, it will be equal to 2. So third Fibonacci will be 3. Third Fibonacci is going to be what, 3. In the same way, let's say I want to find the fourth one. So what it's going to be, fourth is going to be third plus second plus first. Third I have found earlier, so that will be 2 plus first I have, second I have, that is 1, and first is also I have 1. So the fourth is going to be what, 2 plus 1 plus 1, that is equal to 4. In the same way, I want to find the fifth Fibonacci number, that will be equal to fourth Fibonacci, which is 4, plus third Fibonacci, which I found 3, plus 2, which have been given to me 1. So it is going to be 4 plus 2 plus 1, it will be 7. So that will be the whole logic behind it. Let's try to code the same thing. So I want to store all the answers in my array, which I have named DP because it's a dynamic programming. It's a DB problem. So I'm going to call it new int, and size is going to be what? Size will be, because I want to find the nth Fibonacci, so size is going to be n plus 1. Uh, why n plus 1? That is a question which you can ask, because I want to return what? I want to return dp of last, dp of n. But with this, if I write dp of n, if I make the size of n, so with the zero based indexing, if I want to find fifth, it will if I went with like something like this with the deep, if I want to find the fifth Fibonacci, it will give me the last will be what, it will be dp of 4, but I want to get dp of 5. So for that I'm using this dp of n plus 1, and in that also I know dp of 0 is going to be what, dp of 0 is 0, dp of 1 is what, dp of 1 is 1, and dp of 2 is what, dp of 2 is 2. For int I is what, I is going to start from where, I is going to start from 3, because 3 is the first one which I want to find, and I less than equal to, because I want to find the nth one also, so n I plus plus. What dp of I is going to be, dp of I is going to be what? dp of I plus 1 plus dp of I minus 1 plus dp of I minus 2 plus dp of I minus 3. That will be the answer. That will be the whole logic behind it. But we also need to maintain the edge cases. Let's say if n is what? If n is 0, so for that I don't want to run all this, I just want to return 0. If my n is what? If n is 1, then I just want to return what? I'll return 1. If n is 2, then also I will return what? 1, because I have been given that 0 is 0, first is 1 and second is also 1. So these are all the edge cases for that. And let's try to submit the code. I probably think it will give the desired answer, but it has not. Let's try to figure it out where it's not working. dp of I is going to give me what? Yeah, here was a problem. dp of 2 I have written was not that. dp of 2 was 1, so that was the issue with the code. Let's now try to submit it. Most probably it's going to give me the very good answer. It's look time complex. Look at the runtime speed. It's 0 milliseconds. So which says that the time complexity is very good for this one. You can look from here. You can observe it from here that the time complexity is going to be for it's running about on at the most of n times. Yeah, it has to run the O of n times. So the time complexity is going to be O of n, and yes, the space complexity is there, which is also O of n. But by the way, that will also be there if you use a recursive solution. So it's a far more optimized on that with the time complexity and is big O of n as compared to in the recursive solution, which was having big O of 3's power n. So that's an optimization for that. And so yeah, that's all. Thanks for watching this one. See you later.